Okay, sorry. You can hear me right now? Okay.
Yes.
Good. Sorry. Let me restart again. So first of all, thank you everyone for taking the time to attend the Rheinland webinar. Today we are going to share about PFAS related information. PFAS become a very critical topic for all the industry, especially today we will focus on electronic products. For PFAS, this is widely used in various applications, and recently there's more and more study about the impact to the environment and also the health. So therefore, today we will share this topic. There's some housekeeping rules before we start the webinar. About your connectivity to the webinar, if you encounter any audio issue, then we encourage you to dial in by phone based on the webinar ID you receive. If you're unable to view the screen, definitely you should be able to see it now with the screen of Alice. We encourage you to re-log in again. For the Q&A, we will have the Q&A session at the end of this webinar. If you want to place any question, feel free to use the Q&A function at the Zoom platform, and we will try to answer your question as much as possible. After the end of the webinar, we will send you a short survey. Please take a few minutes to complete it, and you will have two valuable benefits. First, you will receive the presentation material from our presenter Alice today. And secondly, we want to offer the opportunity for you to schedule a complimentary technical meeting with one of our experts. And we want to discuss about your challenge and explore tailored solution for your product and for your company. So let's start our webinar. So today we are very happy to have Alice as our speaker. Alice is our session manager for chemical material testing for electrical appliance in Hong Kong. She's the deputy head for chemical regulation TCC, Technical Competence Center, a global-wise organization within Rheinland. And she got more than 10 years experience in the product testing, regulatory affairs related to the restricted substance requirement for consumer product, especially on the electrical appliance. So I let Alice start the presentation. So Alice, please, your time.
Thanks, Nick. Good morning and good afternoon, everyone, and welcome again to our seminar. Today, we will navigate through the complex landscape of PFAS regulation both in EU and US markets. And we will also discuss the latest controls on electronic products. And I will be guiding you through this critical topic that has significant impact to manufacturers, to consumers, and also to our environment. So our agenda today will cover 4 key areas. We will start with a comprehensive overview of PFAS, and then we will discuss the application in electronic products. Following that, we will examine the regulation in EU and the United States. Finally, we will conclude with strategies for monitoring and compliance with PFAS regulation in the electronic product sector. So let's start at the very beginning and what exactly are PFAS? PFAS stand for per and polyfluoroalkyl substance. A family of man-made chemicals that have been used in various industries. They are defined as fluorinated substance with at least one CF3 groups or one CF2 group in a chemical substance. So with over 10,000 types of PFAS chemicals available in the market, they are broadly categorized as polymer and non-polymer PFAS. Non-polymer Polymer-based PFAS chemicals are commonly used for durable water repellent surface coating. So here shows 3 examples of non-polymeric PFAS, and you can see that they all have the CF3 groups and CF2 groups. And then for polymeric PFAS, they are commonly used in manufacturing the materials like Gore-Tex fabric and the Teflon fabric protector. Examples of polymer PFAS is the PTFE, shown in here. So what makes PFAS so special is that they are carbon fluorine bonding. These bonds are one of the strongest in organic chemistry, which confers PFAS with durable water, stain, and grease repellent properties. However, these strengths also make PFAS persistent to the environment, and they are capable of dispersing over long distance through air and water. This makes PFAS earn the nickname as forever chemicals. And due to these properties, PFAS has found their way into thousands of consumer products, including non-stick cookware, and also the water repellent textile, outdoor furniture, some paint, wood lacquer sealants, and also the fire extinguishing foams. So we are now all facing a global contamination crisis with PFAS. The map here shows the extent of the issue in Europe, highlighting the PFAS production facilities, the sites of PFAS use, and the areas where contamination has been detected. So there are 20 PFAS producers in Europe, and an alarming number of over 23,000 sites where PFAS contaminations have been detected. And there are 232 PFAS industrial sites use PFAS to manufacture plastics, paints, pesticides, waterproof textile, and then other chemicals. And there are over 21,000 presumptive contamination sites and over 2,300 hotspots. And the scale of this issue is not only within Europe, it is a global issue affecting numbers of industries and environment. So the global concerns regarding PFAS are multi-phased. Environmentally, they are persistent, they are bioaccumulate and toxic. Some PFAS can accumulate in living organisms and may be biomagnified up the food chain. They can bind to proteins and can be stored in organs such as the liver and blood. And PFAS has a high mobility, which allows them to disperse widely globally, contaminating air, ducts, plants, soil, and water. And PFAS are very difficult to be removed with conventional water purification techniques. And for a human health perspective, PFAS explores has been linked to increase in cholesterol levels, in the decreased birth rate, increased risk of cancer, and some of PFAS are classified in Europe as toxic for reproduction. Here are the media has brought PFAS into the public eyes with the alarming reports. From CNN, it reports on the excessive levels of toxic forever chemicals found in global groundwater. In Japan, there is a news report highlighted the government's consideration of stricter PFAS regulation. And from CBS News, it covered a court's approval of a multi-billion US dollar settlement with 3M over PFAS in public drinking water system in US. So this news reflects the growing global concern over PFAS and the imperative for stringent regulation and control. So now let's focus on the use of PFAS in electronics products. And PFAS compounds, both polymeric PFAS and non-polymeric PFAS, are used throughout the electronic industry supply chain. The desirable properties, such as the flame retardancy, chemical inertness, hydrophobicity, and the dielectric strength, make them valuable for electronic products that operate under high temperature. However, their use raises concern for environmental contamination and human health, especially when they are added to the consumer products. So we will now look at the specific consumer electronic category where PFAS are commonly found. For printed circuit boards, the PFAS is included directly in the laminated material of the board itself because of the flame retardancy and the dielectric properties. Also, it's applied to a finished product of the printed circuit board as a protective layer known as the conformal coating for protection against temperature, moisture, and dust. For capacitor, PFAS can use as the dielectric films because of the high dielectric breakdown strength and the heat resistance. For smartphone and tablets, usually polymeric PFAS are used in coating added to glass, to metal, and the plastic parts of cell phones to make them easy to clean and scratch and corrosion resistant. This is because of the hydrophobicity and the ability to be applied in a thin layer. And then for the liquid crystal displays, it usually contains the fluorinated compounds as part of the actual crystal structure. And then polymeric PFAS are used as a final coating to protect the display panel from moisture because of the PFAS hydrophobic property. And for wire and cables, the insulating layer around the wire and cable are often made from polymeric PFAS because of the resistance to heat and fire, corrosion, moisture, and cracking. For lithium-ion battery, the active material in lithium-ion battery are commonly prepared using PVDF as a binder, and PVDF itself is a PFAS. And for plastic and rubber, the function of PFAS, there are numbers of PFAS function, like as a plasticizer, as anti-static agent, and as a flame retardant because of the non-flammable and the low dielectric constant property. For sealants and the silicone rubber seal, it can be made out of polymer PFAS, for example, FKM rubber. And then PFAS can also prevent the soiling. for electroplating, PFAS can prevent the evaporation of chromium-6 vapor in chrome plating and also prevent the haze by regulating forms and improving the stabilities, because PFAS can lower the surface tension of the electrolyte solution. Also, for some pipes, pumps, fittings, and liners, polymeric PFAS, for example, PTFE, FEP, PF3, and PVDF are used for this application. And then last but not least, the semiconductors. There are multi-functions for the application of PFAS. For example, it can be used as the wetting agent used in etching, cleaning of the silicone wafers, and the non-stick coating composition on the carrier wafer. This is because the PFAS have the low surface tension, and it can use as a strong acid, and also it is stable and non-reactive. So now let's examine the current EU regulation that cover the use of PFAS. So there are restrictions for different classes of PFAS in both articles and mixture in Europe, as outlined in POP regulation and also REACH regulation and 17, which we see a clear framework aimed at controlling the use of PFAS in EU. So for POP regulation, it restricts the use of 3 classes of PFAS, including PFOA, PFOS, and PFHXS. For REACH regulation, Annex 17, it restricts 2 classes of PFAS, including C9 to C14 PFCA and PFHXA. PFHXA, the restriction of PFHXA was published last month, and the effective date will be on 2026 or 10th of October. So continuing with the existing EU PFAS requirements, let's look at the REACH *C. There are currently 11 PFAS were identified as *C. So this include PFOA, PFHXS we mentioned in previous slide, and also other class of PFAS. And the *C requirements mandate less than 0.1% concentration in any article of the consumer product. So moving forward, EU is now considering the significant development, the proposed of complete ban of PFAS under REACH Annex 17. The scope of this restriction is broad for all PFAS chemical substance, with the definition that they have at least 1 CF group or 1 CF2 group. This proposal was submitted by 5 authorities from Denmark, Germany, Netherlands, Norway, and Sweden. They could lead to one of the most comprehensive chemical bans since the inception of REACH regulation. And the timeline suggests a public consultation was finished in 2023, and then with the decision expected in 2025 and proposal implementation in 2026 or 2027, and including a 18-month transitional period. And in terms of the restriction requirement, the proposed concentration limits for PFAS are so as follows. First requirement is applied to any of PFAS. It's required 25 ppb for any one of the PFAS, and 250 ppb for some of the PFAS, and 50 ppm of total foreign content. So it is important to note that there will be use-specific derogation for this PFAS requirements. So continuing with this EU proposal, let's update some of the current status of the proposal. At the end of the 6-month consultation period on last year, September, 56,000 comments have been submitted globally. And this feedback indicates a high probability that the original restriction dossier will need updating. So the next step involves a thorough evaluation by ECHA scientific committees, and then a review of the initial proposal by the 5 national authorities, and then subsequent discussion and final opinions by ECHA. Ultimately, the decision on the restriction will be made by European Commission and the member states. So, turning our attention to the United States, the regulation landscape for PFAS is different from Europe. The U.S. Environmental Protection Agency has taken significant steps at the federal level to address the PFAS crisis, while individual states have implemented their own regulation too. So here is the overview of the state laws, both enact in red color and the proposed bill in black as of June 2024. And this information is important to determine the impact on the product to be sold in US. So we continue with the current existing PFAS regulation in the United States, focusing on the PFAS reporting rule. On September 2023, the EPA finalized the PFAS reporting rule under Toxic Substance Controlling Act, we call it TSCA. This rule mandates the comprehensive reporting from manufacturers and importers of PFAS data dating back to 2011. The EPA has not allowed for any reporting exemption or production volume thresholds. The data submission period will be open on July 2025 with a deadline of 22 of January 2026. For small manufacturers, they can submit the data by 11 of July 2026. So it is important to note that at least 1,400 PFAS compounds known to have been used in the United States since 2001 and will fall under this rule. The non-compliance could lead to significant civil and criminal penalties, emphasizing the importance of this reporting regulation. And continuing with this reporting rule, the EPA requires electronic submission of all PFAS-related information through the Chemical Information Submission System. Manufacturer must report on various aspects of PFAS use, including the byproduct, the production volume, disposal methods, exposure, and environmental toxicological data. They must report all known or reasonably ascertainable information, and in the absence of concrete data, they must provide a reasonable estimate, such as the mass balance calculations, emission factors, or best engineering judgment. Another requirement is toxic in packaging clearinghouse. The TPCH update in 2021 marked a significant step in regulating the PFAS used in packaging materials. It prohibits the sales or the distribution of packaging containing detectable levels of PFAS. And also, please note that there is no requirement limit provided, but the compliance can be proven by the total organic chlorine content less than 100 ppm. Additionally, this model legislation was adopted by different US states, such as California, Connecticut, and Maine, demonstrates a growing concern on the need to regulate PFAS in packaging materials. And also in California state, Proposition 65 has been a driving force in the regulation of all hazardous substances. The inclusion of 3 classes of PFAS, including PFOA, PFOS, and PFNA on the Prop 65 chemical list, and the issuance of the 60 days notice, particularly for textile products, highlights the state's proactive stand on the regulating the PFAS. However, it's important to note that electrical products have not been the focus on this notice to date. And also regarding to the court case under California Proposition 65, we've seen actions primarily in the only in the textile sector. The settlement limit for PFOA set at less than 100 ppm of total organic chlorine is a critical benchmark for manufacturers to consider for checking the presence of PFAS. While electrical products have not been the subject of court cases, the implications of this regulation are far-reaching and require close attention. So as we examined the existing state laws related to PFAS, particularly for cookware and all consumer products, we see a trend that towards a more stringent regulation. So these laws for cookware and all consumer products are already effective in states. In California, for the Bill 1200, applying to all cookware, which are already effective. This generally requires the manufacturer of cookware so instead to disclose on company internet website and also disclose on the product label if the cookware contains certain hazardous chemicals, including PFAS. And for Colorado, the bill is already effective. This generally requires manufacturer of the cookware that contain intentionally add PFAS in the handle of the product or in any product surface that come into contact with food shall list the presence of PFAS chemical on the product label of the cookware and also include a statement on the product label that directs the consumer to a website with information about why PFAS chemical were intentionally added to the product. And for Maine state, it requires to submit the written notice to Department of Environmental Protection if PFAS are intentionally used in all consumer products. The notice should include the product description, the source by PFAS chemicals, the amount of each PFAS used, name and address of the manufacturer, and it will be effective next year, January. Also, Maine prohibit the sales of all consumer products containing PFAS, effective from 2030. And then in another state, Minnesota, it prohibits the sales of the cookware containing intentionally added PFAS effective from next January. And then for all consumer products, manufacturers should submit the information to the commissioner if PFAS are intentionally used. The information should require a description of the product and the purpose of why using PFAS, the amount of PFAS used, and the name and address of the manufacturer, which will be effective on 2026. And then there will be a completely prohibition of the sales of all consumer products containing intentionally added PFAS, effective from 2032. Looking ahead, there are several bills under proposal that could significantly impact the regulation of PFAS in cookware and also electrical products in some of the U.S. states. This proposal reflects a growing legislative intent to address PFAS concern in U.S. and companies need to be aware of these potential changes to prepare and adopt their strategy accordingly. So in California, it's proposed to prohibit the sales of all consumer products containing intentionally added PFAS and proposed to be effective on 2032. In Colorado, it will prohibit the sales of cookware containing PFAS and effective from 2026. In another state, Connecticut, it plans to prohibit the sales of cookware with intentionally added PFAS unless the manufacturer could provide the notification to the Department of Energy and Environmental Protection. Planned to be effective from 2026. And then effective from 2028, no person can sell the cookware containing PFAS in Connecticut. And then in Illinois, it proposed the prohibition of sales of cookware containing PFAS planned to be effective from 2025. And then for all consumer products, it is prohibited to be sales containing intentionally added PFAS effective from 2032. And then in New York State, it prohibits the sales of cookware with the intentionally added PFAS used unless the department has determined that the use of PFAS in such products is currently an unavoidable use, and it's planned to be implemented in 2027. And for all consumer products, New York plans to prohibit the use of PFAS for all consumer products effective from 2032. So in summary, the effective state laws for PFAS in the U.S. present a clear road towards the stricter regulation, from the TPCH prohibition of PFAS in packaging materials to different notification requirements and the bans coming into effect in the coming years. The regulation environment is rapidly evolving. Notably, the bills under proposal set to become effective starting in 2025 signal an important move towards a full ban of PFAS in all consumer products from 2030. So going to our last session, we will discuss the critical topic of PFAS monitoring and the compliance strategy for electrical and electronic products. As we go through the complexities of PFAS regulation both in EU and in the United States, we are offering a comprehensive range of analytical services. These services are designed to detect both intentional and unintentional use of PFAS in products and enable manufacturers, brands, and retailers and suppliers to meet their legal obligation under EU and US requirements. We are offering a 4 distinct test packages to fit different regulation needs. For package 1 is tailored to cover the 5 effective PFAS requirements in EU. For package 2, expands on this, covering up to 311 PFAS, target PFAS, including those in package 1. For package 3, focuses on the testing for total fluorine content, aligning with the EU proposed restrictions. And then for package 4 is designed for the US requirements, testing for the total organic fluorine. So these tailored test packages can ensure that your products are not only compliant, but also safe for the consumer use. So in comparing our test packages, the target PFAS test offers a precise identification and quantification of 311 target PFAS substance, ensuring the compliance with the 5 effective regulations in EU. However, it comes with a higher cost and a longer testing time, and does not cover the number of PFAS substances beyond the targeted list. For total fluorine test, it offers a cost-effective and a quick preliminary screening tool, assuming that the total fluorine is indicative of PFAS presence. Yet, it does not differentiate between the organic and the inorganic fluorine detected, and cannot provide the specific PFAS concentration. Lastly, the total organic fluorine test also serves as another preliminary screening tool with a lower cost, but it does not offer a specific PFAS concentration levels and has a longer turnaround time compared to the total fluorine test. So, identifying the high-risk materials in electronic and electrical products is a critical step in PFAS monitoring and compliance. These materials include the fluoropolymers, such as the PTFE polymer, FEP, PVDF, and FKM rubbers, and the non-stick coating in food contact materials, coating with water and oil repellent function, the anti-corrosive coating, and electroplating like the chrome plating, nickel plating, and copper plating. Other high-risk materials include the printed circuit board and cable wires, PC polycarbonate polymer, and the silicone rubber steel, lithium battery, capacitor, and semiconductor. Apart from the testing services I've mentioned before, we also help customers in pinpointing these high-risk material, thereby enable the companies to take the proactive measures in their product testing. So here we can explore some of the availability of the alternatives for PFAS used in electronic products. The table presents here shows the product category where PFAS-free alternatives are already on the market. For the printed circuit boards, to replace the PFAS protective coating function, it can be replaced by using the acrylic resin, the urethane resin, silicone resin, and other epoxy. For capacitors, to replace the dielectric film, the available alternative polymers include PP, PE, PET, PPT, and more. For liquid crystal displays, depending on the application, the most suitable alternative would be the use of different display technologies, such as the LED or the plasma screens. For wire and cable, the PFAS insulation function, the best alternative would depend on the specific function need, but there are some options available, including PVC, PP, PE, silicone, and others. Also, for the non-stick cookware, for replacing the non-stick function, the safer alternative, such as the cast iron, stainless steel, ceramic coating, glass, and also the enamel coatings. So lastly, the ultimate goal is to phase out PFAS in your supply chain effectively. So this also involves a multi-step approaches. By communicate with your supply chain to identify and understand the use of the PFAS in your product, and then to compile a comprehensive catalog of PFAS use in your electrical products. By identify the non-PFAS alternative that meets the performance needs, also considering the technical feasibility, the cost issue, and the life cycle impact. And then by monitor the phase-out process to ensure that the alternatives do not lead to the regrettable substitution, but to provide a safer and effective solution. So this is the end of my presentation, my sharing today. And we've covered a lot of information today. So now is the time for any clarification and questions.
Yeah, thank you, Alice. I think this is very informative presentation. Let's proceed to the Q&A session. We received quite a number of questions from the participant. Let's start with some simple questions as a warm-up. The first one that is coming from about for the product packaging of the electrical appliance or products, does it also fall under the scope of PFAS regulation? So I think it's related to the packaging material of the product.
Yes. For in US, I've mentioned TPCH is for PFAS for packaging materials, and then for EU and the proposed ban of PFAS may be effective from 2026. It now is also undergo discussion whether the packaging material is also within the scope.
Okay, thank you. And then the second question is about for the to Rheinland. So I think, Alice, you mentioned that we can provide testing for the target PFAS.
Yes.
Would it be possible to share a little bit what is the test method we are using and what type of analytical equipment we are using?
Yes, for the target PFAS testing, we are now in Hong Kong, we can test 311 PFAS, and the number will be increasing because we are developing the new testing methods for the increasing number of PFAS. And then we are using the in-house method, and then determination by the GCMS, GCMS-MS, and LCMS-MS. So it involves different numbers of instruments.
Okay. So then basically we use multiple equipment in order to cover the more target PFAS for this case.
Yes.
Okay. Then the other question I think is quite interesting is about Alice, you shared about PFAS, ban of PFAS restriction, but from industry point of view, this is also a challenge for the industry to find an alternative for the PFAS.
Yes.
Is there any common known solution or replace material for the PFAS related plastic, for example, PTFE, FEP, PVDF? I think you have some slide, maybe can do a quick recap on this information.
Yes, I've shared some examples for the available non-PFAS alternatives, and then if but on this slide is some examples of the alternatives. So if you have the specific application that you would like to ask for the available alternatives, and you can ask me maybe after the seminar, then I can help to check with the possible alternative. Because it depends on the application, and also depends on the use of your product.
Yeah, exactly. I think the key point will be about what is the final application of this product or this material, because I'm sure for some application, the industry already have an alternative, but some application may not have a, let's say, perfect alternative. Maybe the price is too high. Maybe the material, I mean, the new material is not ready. But if you want to discuss about what would be the possible one for your current concern, feel free to leave your contact information, and then we will try to set up a meeting with you. Okay, then let's proceed to the other one. How would the EU proposed restriction be applied to compressed article like electrical appliance, for example, a coffee machine? That use PFAS containing semiconductor, will it be applied to each assembly article or part?
Yes, from the proposed regulation is should be applied on every single articles. So just like the REACH regulation, it's applied to if this is a complex product, then the requirement should apply to every single articles within the complex product. So there is no involved in any ratio calculation.
Okay, very good. Then the next one is about the test methodology or test approach that we have. The question is about in EU, it can test some of the PFAS based on which Annex 17 or POP regulation. If a customer need to confirm the product do not contain PFAS, is there a single test can cover all of the requirement, or we need to use multiple approach? I think maybe you can go back to the slide of the test proposal by Rheinland and then explain the more detail.
Okay, so for EU effective restriction, then package 1 would be good enough. But if clients would want to cover more PFAS, then package 2, which can cover 311 PFAS, would be it would be a better solution. But because we've mentioned there are over 10,000 PFAS in the market, so for better solution is to test the total foreign content together with the target PFAS. And then for total foreign content, it can also identify the polymeric PFAS, because for polymeric PFAS, there is no testing method to identify. So it can be only be calculated by testing the total foreign content. So I would suggest to test the target PFAS plus the total foreign content together for complying the EU proposed restriction.
Thank you, Alice. So maybe let's pick one more question before we close. So this is also an interesting question about PFAS-free KIM. So I think this is also quite tricky because the customer want to make a PFAS-free KIM on the packaging of the product. Would it be good to make this advertisement for EU and US market? And if this is possible, then what is the validation activity you propose to them?
For PFAS-free cane, as I mentioned, there is no testing method that can cover 10,000 PFAS at this moment. And then also, if you by testing total fluorine content and total organic fluorine content, it's only an indication that there is no PFAS. But if for claiming for the PFAS free, you should ensure that there is no PFAS, not only by testing, but also by the supply chain management, by the declaration of your suppliers to ensure that the full manufacturing process is PFAS free. Yes, and then maybe Nick can give some comments, as I know there is some greenwashing requirements in Europe.
Yeah, I think at this moment, as mentioned by Alice, we have quite a big family of PFAS, and there's also no single test methodology can cover the validation of these, let's say, absolutely no PFAS in your product. So I would say this is not really to recommend to do so, but if you really intended to make this claim on your product packaging, then we suggest you to really make a comprehensive study on the product situation. So maybe it will be good if you want to have a more detailed discussion with us. Then let's have follow-up discussion on this point. Okay, so here we come to the more or less the end of our webinar. So I would say that really appreciate very much for everyone stay until the end of webinar. And I hope today's session provide really the informative on the PFAS regulatory landscape and also to finance solution. You will receive also the survey, the link for the survey later on. So as I mentioned, if you want to have the presentation material from Alice and also to have a technical discussion with our expert, then please fill in the survey, your contact point, your willingness, and also your schedule for the meeting, and then we will get in touch with you for the follow-up. So if you have any questions related to any issue for PFAS, then feel free to contact with me and Alice. You can see our contact information here. I hope you enjoy our session, and we are looking forward to see you in our next webinar series. Thank you. Then have a nice day. Bye-bye.
Thank you. Bye-bye.